Hello. If your platform name is just prompting AI, basically pasting Terraform error into a chat window, perhaps even copying the answer book, running it, pasting that next error, and trying to figure out what's going on, you are using AI the old way. When I say old way, like how all of us used to use it maybe 12 months back. So the industry has moved on from this prompt engineering to what we know as the loop engineering. And in this talk, I would like to talk a little bit about loop engineering and how that fits in within the platform engineering space. So nowhere does this matter more than in platform engineering if you're really looking at the context of it, because our entire job is about more of those repetitive, checkable, high toil work and how to actually reduce that down to load in doing that. So things like a drift detection, pipeline failures, catalog hygiene, um, patch triaging, and whatnot, right? I mean, so this is exactly where the loops really shine. So, what I'll talk about today is like what has changed and how loop engineering actually works, and the specific loops platform and DevOps teams are literally running today. So, the whole idea is that using this, you can actually get your platform to start improving itself while you're not really doing anything, right? It can happen in the background. So, let's start with something very simple. So, to understand why loops are now possible, you need to understand one fatal flaw in LLMs, right? So, if you really look at LLMs, there is some major issues there which we can actually solve here. So, think of LLM as a genius. So, these are like new models, right? Your look at your Claude Fable 5 or GPT 5.6. Now, these are really brilliant models, right? I mean, at pretty much any task that you want to do. So in this case, the task that you would be doing would be things like writing your Helm charts, maybe debugging your GitHub Actions workflow, or reviewing a pull request. So this, when it's actually doing all of that, this LLMs comes with some level of amnesia. By that, what I mean is that its memory is one whiteboard, that context window, and every instruction, every error message, maybe every retry that gets scribbled on that whiteboard. And when it fills up, it starts forgetting and it starts a new session. And you might have seen this even while you're using perhaps Claude or ChatGPT or something like that. What happens then is that your whiteboard is, sort of wiped clean, start from scratch. So let's actually look at a quick visual to see how this sort of fits together. All right. So what you're really looking at is that um, on the right side, essentially, you're saying that here you were that loop, right? So you prompt something like, why is this deployment failing? And it basically answers, say, here is the reason why the deployment is failing. So you check the answer against that cluster, you then reprompt with that actual error, and the answers again. So then what you do is like you sort of apply it, you say kubectl, then that won't work, then you paste it back in. So you were that middleman between that genius LLM that forgets some things at times and then work that actually needs us to move along, right? So you were that loop, you were that connective tissue between all of that. Now, that's what prompt engineering uh, was. I mean, so in that case, that was that skill that you had. You needed to know how to prompt it. Essentially, you had those one instruction, one response, so that um, the better you are at providing those instructions, the better you are at getting those responses. All the content that we did in 2024, maybe 25, was like how to perfect that prompt. It was a workaround for models that couldn't check their own work. And you might have heard a lot about prompt engineering is dead, right? Now the question is like, what happened? What changed? So here is what changed in the last few months. The models got really, really smart so that they could actually start evaluating their own output. So that sounds like a pretty small thing, right? It's not small. It's that difference between how a junior engineer who would need every code review spelled out and a senior engineer who can hand it, you basically give them a ticket or give them a task and you trust them to do the right thing. So if you listen to the people actually building these systems, the engineers at the labs, not the people who just talk about it. So the people who are actually building it, the number one theme, what we see is the loops. So try something, essentially check it, fix it, try it again. Because when a model can reliably tell whether its own work is correct, you no longer need a perfect prompt, right? I mean, so you just think about it. And you need what you really need is like more of that well-defined goal and a way for the model to verify against it. So, and platform engineering is uniquely positioned here. So for one reason, so that your work is verifiable. A pipeline is typically green or it isn't, right? It's not somewhere in the middle, because a Terraform plan, if you were to do it, it can show the drift, or it won't, right? So the service has an owner in the catalog or it doesn't. So it's more or less that binary situation where you can actually look at it and see, is this really going to be work? An objective measurement or a subjective measurement. Because if you write a document or if you write a marketing copy, for example, that can be subjective. Whereas something like infrastructure is something that is checkable and more objective. So loop engineering typically needs things that are checkable and have, you know, the checkability, if that's a word, happen everywhere. So now let's look at what happened between the prompting era versus the loop era. The shift is what you can see in that this diagram is that shift, right? So in the old world, essentially you are in the middle. So what is happening is that your genius with amnesia is on the left, your infrastructure is on the right. So you're shuttling between both of them, trying to be friends with both of them, trying to make sure both works. Statistically, this is still how most engineers use AI. In the new world, the AI starts running the loop itself. So it attempts the work, say fixing a flaky integration test. It runs a test suite. Then test fails. It reads the failure, self-corrects, tries again. So it keeps looping internally until the work verifies. And only when it does not work, it sort of comes back to you. So you're moved from inside the loop to be on top of it. So you still review. You're not completely giving away your authority to be able to do something. So you still do some course correction activities, which I think you should, but you have stopped being that transport layer between the model and the terminal, right? So you got to go from that micromanaging a worker to being an engineering manager to more of that engineering manager where you can actually define what definition of done means. So what does that loop entail? So if you really look at the anatomy of a loop, every well-engineered loop has primarily four pieces. So if you get these right, you can trust that this is actually going to run unattended. So number one, the spec. So this is where you talk about what is done in operator terms. Reconcile your Terraform state against what's actually running in the prod. Then number two would be the checklist. So this is, as we talked about earlier, your definition of done. This is a part where platform engineers already know how to write because it's more like an SLO, right? So because done means every drifted resource is either reconciled or written up in some kind of drift report, markdown file or something like that. And it has got things like your severity of the issue, root cause, proposed fix, and everything. So it's not a generic advice, but finding references in a real resource kind of thing. The third one is inspector. So this is interesting because this is where model reviews its own work. So it can be even better, right? So you can orchestrate a second model as the reviewer. So your contractor and the site inspector kind of thing, right? I mean, that kind of a relationship. So work doesn't get marked done until it passes that inspection. And this is exactly that control loop we are all familiar with. So Kubernetes has been doing more of this observed state versus decide state since, I don't know, 2015, right? I mean, a lot of you would have done all those reconciliations. So loop engineering is that reconciliation loop when your controller can actually start doing the reasoning. So number four here is the budget. This is very important. So loops without limits are how you burn the API budget overnight. The API equivalent of a crash loop, like crash looping pod, right? I mean, you're familiar with in the Kubernetes world, with no kind of back off. So I think that is what you should be sort of having your mental model as. So you should be able to cap it. You can say things like stop it n number of attempts, 3 attempts, 10 attempts, whatever, right? And then you can sort of also say, in this current terminology, you could say like stop at very specific number of tokens. So that retry budget is like your error budget in this case. So you can see the parallels in how we would do this in the platform engineering world from what we have been doing in the new world. So think of it like your spec, checklist, inspector, and budget. So that's that whole discipline. Now comes the idea of inner loop versus outer loop. I'm pretty sure you're all familiar with this whole idea of inner loop versus outer loop, but let me just take a moment to talk about it. Two kinds of loops, right? And the DevOps people, know about these things very quite easily. So inner loop, if I were to define that, is that single mission that self corrects until done. So you have your, let's say you audit our golden path template against our current security baseline and list every gap with a fix. So that's one instruction. But the AI, the way it sort of works is the AI sort of orchestrates that whole cycle inside it. So what would they do? So they'll try and scan it, check its own findings, catch its mistakes, verify, and then mark it's done, right? So that is that inner loop. Now comes outer loop. It's the same job on a schedule. So every hour, every night, let's say every Tuesday evening or whatever, this is where it sort of starts compounding, right? So you'll have things like your nightly loop reads, yesterday's CI failures across every repo, classifies what tests are flaky, what tests are real, then quarantine some of those flaky tests and updates the report so that your team can read over, the next morning. So basically that whole thing runs when you are not really babysitting it, right? So it's checked, it has checked its own work, and it'll run again tomorrow. It'll run on a schedule kind of thing. So your outer loop for cadence is what you should be thinking about, and your inner loops, you're doing the work inside each run. So, and no, we're not talking about wiring all these things up by hand, right? Don't do it. In Cloud Code, you can just express the mission with a slash goal, and the cadence with the slash loop. The whole orchestration happens on your behalf. So the goal is the mission, and the loop is that interval. So if the goal isn't precisely defined using slash goal, the loop can't know when to stop, and that is a problem. So that's the reason why that checklist matters a lot. So let's try and make this a little bit concrete, right? So when you really look at this, so a typical slash goal could be like, I might say slash goal audit our backstage service catalog with a like a platform consultant would do. And I don't want to pay the consultant, $5,000 to do it. I just want to do it free or using my tokens, right? So I'd say, and write the findings to a catalog audit, and done if it is done when at least 10 specific issues are listed, with every issue having some level of severity, an exact component affected, a fix that could ship today, whatever, right? Then say that if it can't do this in 12 turns, stop it. So now you can see what I said, right? So we are talking about things like, so let's look at this one a little bit. Yeah, so let's look at things like um, the spec, the checklist, the budget, all of them are in one instruction. So I think that is the way in which we should be doing this. Now comes the loop library for platform teams, right? So we talked about the concept of loops, why loop is different and what loop engineering is. But what are those real defined cases that you could have, right? So let's look at a list of cases that we have here. Um, Now I'll just go over each of them. So first one, what I have here is what I call as a drift sentinel, right? So this is a nightly run that you could have. What would be happening there is that compare your IAC state to reality. Do some auto reconciliation, and then write up the rest, right? I mean, that would be one thing you might want to do. So this next thing is more of those flaky test triage. So your flaky trust triage would be like, every night classify the CI failures as part of your CSAD, and quarantine the flakes and issue and sort of should be created, an issue created for each of those ones. Third one would be a catalog hygiene. So this would be where you talk about a weekly score. So essentially on a weekly level, you'll have a score that says every service, how are they doing? So what are the who's the owner, what are the docs, run books, on call, and all that kind of things. Make sure that you nudge all those gaps there. Another one that we have used ourselves is like golden path freshness. So what you would be doing in this case is on a weekly basis, you could actually diff your templates against current baselines and then open these upgrade PRs. How phenomenal is that, right? Think about it. Another one is patch triage. This has been getting a lot of press. You might have heard a lot about this one. So this is where we talk about on a daily basis, create a cluster of all the vulnerability alerts that you might have, right? Rank by exposure, draft update PRs, and say, okay, here are the top three, right? Next one would be your cost anomaly watch. So this is something that you can do daily. You can actually look at it and say, hey, I'm going to scan the cloud spend deltas and explain why that spike happened in plain English that anybody can understand. The last one there would be more of those adoption digest. This is a big classic problem for everybody. So this would be like on a weekly basis, you could say, you could pull all the platform usage metrics into one page and just digest it for leadership, right? So the state of platform engineering report that we actually put out from platformengineering.org found that I think about 30% of the platform teams don't measure success at all, right? So the teams that can't show value inside the first 12 months would get defunded. When I have conversations with lots of leadership, lots of people who are struggling with getting the adoption going, first thing I ask is, are you actually measuring your success? Are you actually setting your definition of success? And a lot of the times people say, yeah, it's a little bit all over the place. Nobody knows what that is. And that is where the problem is. So treat your agents the way you treat new engineers. You should onboard them. You should give them the context about your stack, define what that done is, set the cadence. And an agent with no context typically fails exactly like a new hire with no onboarding. So you spend years building these golden paths for developers. Now start building that for agents, and they are your platform's best consumers. So here's a takeaway. Your prompt engineering was you compensating the models that couldn't check their own work. That era is completely over. So loop engineering is where you are actually defining done, your spec, checklist, inspector budget, and letting the model close its own loop against it. Platform engineers, in my opinion, should be the best in the industry at doing this because we have already done this. We have been doing this for Kubernetes and a whole lot of things in the past. We've been thinking about control loops and reconciliation even far many, many years before it was cool. So all those primitives are the same. The controller just got a brain now. So what you should be doing is that library I showed you, pick one loop from the library. Start with something like a flaky test or drift or something that's closest to your heart. And then run it nightly for a week and see what lands in the report. And then subscribe, because next step is like putting these agents into Slack so that your whole team can start dispatching them. So that's basically what I wanted to share today. Hopefully, this was useful, and I will talk to you in the next one. Thank you.